All right, we'll go ahead and get started.
The broadcast is now starting. All attendees are in listen-only mode.
Okay, I hope everyone can hear me. This is Lincoln Cobb of the Federal Highway Administration. I have the pleasure to be the moderator today on a session that I hope will be found very useful by a wide-ranging audience. I'm going to invoke my moderator's privileges to speak very briefly before we get to the headliners about a couple of points that, or a couple of observations that I can make as somebody from the Federal Highway Administration. And first is to say that the commitment to data and data-driven decisions reaches right down from top to bottom in the Federal Highway Administration, and that's not going to change. And it comes from principles that all of us are very familiar with, and you can see there that we can't manage what we can't measure. I first saw that attributed to Bill Hewlett of Hewlett and Packard, but for all of us, data-driven decisions are crucial if we're going to be able to get the best out of the limited resources that we have. So for us anyway, and I think after you see what Stan is doing, it's going to be clearly beneficial to our entire community, that collecting good data, using it well, analyzing with it is something that we're going to be doing more and more of. For those that have taken the time to take a look, MAP 21 is the new highway bill, and that only shows a further commitment to the effective use of data. The states are going to be asked to develop performance-based asset management plans. The Highway Safety Improvement Program is still there and further highlighted, and I quote from there that it emphasizes a data-driven strategic approach to improving highway safety. So it's data and its use is here to stay. For the vendor community, it means that there's going to be growing business opportunities for the collection and delivery of data and, in some cases, analysis. A couple of key issues. First is that we're all still learning. Government, we still have a lot to learn on how we specify the jobs that we want done. How do we write requests for proposal? And Stan and Scott are going to provide you one great example of that. Mobile data collection and the use of that data is still in its early stages. I say that not because LiDAR hasn't been around for a while, and the different position measurement equipment haven't been around for a while, but because we still do not have singular national consensus standards. So there's still kind of a Wild West feel in this field. New technologies and processes are emerging daily, but we don't yet have that one yardstick that we all share that will allow us to tell how good all those new technologies are. And the last substantive thing I'm going to leave everybody with is just from my standpoint, QA/QC right now is hugely important. It cannot be overstated. And this also goes from the vendors and suppliers up to government. We need to challenge ourselves with this question: how do we know how good that our data is as good as we think it is? There have been plenty of examples recently where good companies have believed that they were able to provide certain measurements to certain tolerances, and it hadn't happened. A couple of things: realistic comparison with ground truth, I think, is very, very important. This is a little bit of my personal opinion, but periodic independent audit of your own internal QA/QC. If you're not doing that, it's an opportunity missed to really cement the sort of product quality that I think all of us are interested in. I do want to point to something, give an acknowledgement to the Utah DOT. Their U-Plan is now part of the second FHWA Everyday Counts program. And I'm not going to talk more about that, but invite folks to follow that link and see a bit of how we're going to be making use of that particular, of the progress that Stan and his team have made. With that, I get to the most enjoyable part of my role, and that's to introduce the speakers for today. Stan Burns is the Director of Asset Management for the Utah Department of Transportation. He's a registered professional engineer with 25 years of experience, and during that career he has held positions in design, operations, planning, and program management. Thanks for being here, Stan. Scott Jones is also with the Utah Department of Transportation. He's the Safety Programs Engineer in the Traffic and Safety Division. Scott is responsible for administering federal and state safety initiatives and programs such as the Highway Safety Improvement Program. He's a licensed professional engineer and a professional traffic operations engineer. Welcome, Scott, and at this point, I hand off to you two. Thank you.
Thank you, Lincoln, for the introduction. This is Stan Burns. And UDOT, Utah Department of Transportation, is very pleased to be given this opportunity to show you our program of data collection. Hopefully you'll find this interesting. If any time you have questions, just type them in and we'll answer them on the fly as we go. This presentation is going to be given by Scott and myself. We're going to trade off. I'm going to start with the introduction. Scott's going to give you an idea of the journey we went through just to develop an RFP and select a contractor. I'm going to then talk a little bit about UDOT and their asset management program and give you an idea of some of our successes and how we want to replicate that for all the other assets we're collecting on this project. Then Scott's going to jump back in and talk about our crash management system. And it's pretty exciting. For the first time, we're going to be able to overlay crashes, geometry, and assets to be able to do a really great job on our management of safety. And then I'm going to finish up with conclusions and where we're going in the future, our dream of what we want to do with all this data. And so anytime you have any questions, just write them in there and we'll get to them. A while ago, the Utah Department of Transportation started on this journey to collect all the assets on all the highways. We have approximately $30 billion of inventory, such as pavement, bridges, signs, culverts, just to mention a few. At the end of this project, we will geolocate every single one of those assets. We'll know where they are, how many, the condition of many of those assets. And for the first time, we'll be able to put together very rigorous asset management or safety management projects and programs. So I said we were collecting everything on the roadway. And the reason for that is if you do not collect, if you do not know what you have, if you do not know the condition of what you have, you can't manage it. As Lincoln said, if you can't measure it, you can't manage it. So what does that mean? UDOT is responsible for 5,800 centerline miles. We're going to be collecting data in both directions and all on the ramps and collectors. So that turns out to be 17,000 driven miles of roadway. We can only do that because technology is improving daily. And so the technology of today is vastly superior to yesterday's, and tomorrow's will be even better. So for the first time, we're able to collect data at highway speeds, geolocate that data, and now we can do analysis on that data. So the project was started here in systems planning and programming, but the champions are many. This is a department-wide effort. The two major champions besides systems planning and programming are traffic and safety and central maintenance. But besides that, we have structures involved, we have motor carriers, we have GIS, we have right-of-way. And that's one of the keys of this effort. It's not us working in silos. traffic and safety doing his thing, and me in asset management doing my thing. We're going to collect all these assets in one pass. We'll have a point cloud for the entire system. And very importantly, we'll have an integrated workstation. And so customers, other people in the department will not have to go to Scott to get one part of the puzzle solved and me another part. So without further ado, I'm going to turn it over to Scott. And he's going to talk a little bit about the procurement process.
Thanks, Dan. We went through quite a history to get to where we are. I'm going to try to step you through a few of those steps. Where did we go? Keep going.
Scott, let me do it for you.
Okay.
There.
Thank you.
You're
Sorry,
welcome.
we got some slides mixed up. We had a multidisciplinary team assembled, as Sam described, representing various groups in UDOT who came together to first have presentations from 12 different vendors that came in and showed us what current technology was and what they had to offer. This was vital as a first step for us because it helped us to know what requirements to write into the RFP. This group stayed together in developing the RFP and the requirements for each of the data elements that were being collected. After the RFP was advertised and we had our list of responders back, we embarked on a multi-step selection process where, first of all, the team reviewed written proposals who were then shortlisted to the top 3. And those top 3 came back to give a proof of concept type demonstration where we gave them all the same section of roadway, 2 different types of roadways to collect data on, and then come and present that information, what they had collected and what was possible to collect, as well as a day with each vendor just sitting down and understanding their software and their user interface and how easy it was to interact with the data. This was key to us to make sure we just weren't data rich and information poor, but that we were able to utilize what was being delivered to us. So here is our project timeline. We began the RFP development in spring of 2011. Through that summer, we had these vendor demonstrations. The RFP was advertised in October. Selection was made in January. Manley Communications was selected as the top vendor for the project. There was some post-selection work in refining what data elements were being collected in the data dictionaries. Collection has proceeded this summer, completed last month. We've started to receive delivery of some data elements. Final delivery will be in March of 2012. The final delivery includes the extraction of all the assets out of the LiDAR point cloud.
Scott, let me just jump in. That is a typo. It's March of 2013.
You're right, it is a typo.
Yes.
And I read right over it without recognizing it. So collection was complete last month. Final delivery of all data elements will be early next year. And as I was saying, for the asset side of the collection and delivery, that will include asset extraction out of the LiDAR point cloud and the high-definition images we're receiving. So as Dan mentioned, primary funding for this program was shared between planning and programming, central maintenance, and traffic and safety. The initial contract for this initial data collection effort is roughly $2.5 million. The contract allows for ongoing data collection and renewal of the data and several extensions beyond that. Our obstacles and lessons learned. First of all, we have become aware that everything that's being delivered to us will be literally terabytes of data. And trying to manage the storage of that data, the retrieval of that data, the use of that data has been a little bit more challenging than we were frankly expecting. Now that you can walk down to the corner store and buy a 1 terabyte hard drive, trying to get all that data, though, communicated and shared across a computer network, it isn't as easy as it sounds at first blush. It was important for us to build consensus among leadership here at the department. Obviously, putting this much time and resources and money into this project, we had to make sure we had support from senior leadership. The procurement process was lengthy. We used both state and federal funds for procuring. We had to follow both procurement rules and navigating through those waters and keeping all the contracting folks in line and on target was something that needs to be planned for. I can't talk enough about how important it is to have a good working relationship with the vendors. They're the ones providing the information to you, and we found we had a tremendous stake in this, given how much money and time and commitment we had involved with the project. And those working relationships with the vendor and building those relationships are vital. Can't say enough about them. A final bullet on this slide. When you get all these people at the table, the vendor and the internal groups, obviously the wish list of what to collect can get enormous. And it's important to keep in mind through this process without stifling ideas and innovation, to have the goal and end vision in mind about what is critical, what is mission critical to collect, especially for a first go around. So let me talk briefly about what is being delivered to us. First of all, we're getting high definition imagery of the right-of-way. You'll notice from these pictures, it's a 180-degree image, 3 separate high-definition pictures being stitched together to get the 180-degree image. Then we're getting a workstation that's combining all the data into one place that can be queried and retrieved and viewed. For example, you see the high-definition right-of-way imagery in the right here. The middle is the downward-facing cameras for your pavement conditions, as well as different tables of data that you can query and move to the data set. And then we're getting a mobile LiDAR imagery of the entire state system. This has the gee whiz and the really cool whiz bang factor of just looking at it and navigating through it. It also has some additional advantages that wasn't spec'd in the RFP as being a requirement that LiDAR had to be used. But it provides additional advantages that we will touch on more as we go through our presentation. I want to point out that we had in mind as we were progressing through this project the Meyer elements, the model inventory of roadway elements that was published by FHWA in 2010 for basically FHWA's wish list for what roadway and roadside asset and elements we could collect. We also had the memo in hand from FHWA from 2011 that listed 38 key elements for safety analysis that should be collected and available. In the end, this is high-level categories of what we ended up in our requirements and what we funded to collect in our project. We have pavement distress, roadway geometry, pavement surface conditions, signs, sign inventory, structures, data of our structures, of our walls, of our pavement markings, intersection inventory, billboards, and our roadside features such as barrier and guardrail. We really see the benefit of having all of this data for all of our business groups and systems. We are going to store the data inside our different business systems in the department, which primarily resides within Oracle databases. We are also going to make it available in a GIS data warehouse. And a little bit later in our presentation, we will also highlight some key features of UPlan, as was mentioned in our introduction. So we are really excited about the idea of, as Stan mentioned, combining our asset management, our maintenance, our safety data elements into centralized locations and workstations where it can all be viewed in one place by multiple users for multiple purposes. As referenced just a moment ago, one of the key benefits of the LiDAR point cloud is that if we chose not to have certain data elements extracted and delivered to us at this time, it allows us to go back and extract additional elements at a future time, either ourselves or go back and pay the vendor to do that for us, which offers extreme flexibility of not having that anxiety of, are we collecting enough, did we do enough the first go around, as opposed to purchasing the Cadillac up front, if you will.
So I think it's back to me. Lincoln mentioned the importance of quality control and quality assurance. We have 30 terabytes of data when we're done. 25 terabytes of LiDAR, point cloud data, 6 terabytes of images. That's 200 images a mile in each direction, so it adds up quickly. And then we have about a half a terabyte of asset data. So how do you make sure, how does the vendor make sure that this information is correct? How does UDOT make sure it's correct? It's been a challenge. So in the initial RFP, we put several key issues we thought was, one, the contractor had to bring an independent firm with them that would provide quality assurance. That bullet, the next bullet we're looking at, weekly meetings. We have a stand-up meeting every Tuesday at 3 o'clock with the contractor, and the contractor displays how they are doing quality assurance. And this picture that I have shown there is just one of the ways that they're looking at specific values to see if they make sense. And if not, they look at the photo log. And so you can't look at every bit of data, so you have to scientifically, strategically look at specific assets, look at them if they're out of range, and then proceed with doing the quality control, quality assurance based on what you learned before. So the weekly meetings is just our gut check that the contractor has a very rigorous quality assurance, quality control program in place. Then we have an ongoing internal effort. So each group is responsible for their particular area. So Scott's group is responsible for safety assets, guardrails, cable barrier, rumble strips. The maintenance group is responsible for signs and things like that. My group is responsible for lane miles, pavement distress. And then I mentioned the consultant contract provides additional QC/QA activities. And another bullet that doesn't show up here that's really important, we provide incentives and disincentives in the contract. The incentives for this contract can be $100,000. The disincentives can be $50,000. The purpose of those incentives and disincentives was to, our goal here at UDOT was for the contractor to get 100% of the incentives and work with that contractor to help them achieve that. As I said, there's no way we can check on 30 terabytes of data. So we wanted the contractor to be serious about doing QC/QA. If we see things, if our groups see things, we immediately call the contractor and say, did you know there's a problem with this particular asset? The way we do the incentive, disincentive, we go out 5 times over the course of this project. We randomly select 5 areas of the roadway, and we look at 5 different assets. We look at cross slope. We look at profile. We look at rutting. We look at the surface areas, the square footage of surface areas, and finally we look at signs. So next I'm going to talk to you a little bit about the importance of asset management. First, you have to have asset inventory. The reason why we're doing this project is we want to know where those $30 billion of assets are. We want to know the condition. And from that, we'll be able to put together programs where we can manage that asset. And I'm going to go through about 4 slides here and describe our pavement management system, because we have a pavement management system that's very robust. It's well respected across the country and within the industry. And we want to model our future asset management programs on our pavement management program. So having said that, we have a motto here at UDOT called Good Roads Cost Less. And the theory there is if you know where your asset is, if you know the condition, if you know the deterioration of that asset, if you have maintenance strategies for it, you can put together plans that address very effectively the best way to minimize cost and prolong the life of that asset. So it's part of our culture here. It's about keeping pavements in good condition with well-timed treatments. But this applies to any of our assets that now, for the first time, we're going to have the ability to manage, whether it's signs, signals, our safety program. So how do we do this in pavement? For the last 5 years, we've been using contractors to collect pavement distress at highway speeds. They've been driving 17,000 miles, and they're measuring a continuous survey of that pavement surface. They're picking up cracking, faulting, rutting, and it's a quantifiable amount of faulting, a quantifiable amount of cracking, the width, the depth, the length, and the rutting. And most importantly, this is all done, it's all automated. The software of the vendor is measuring the length of that crack, the depth of the crack, the width of the crack. So it's not somebody saying, I think this crack is a 7 on a scale of 0 to 10. It's all quantifiable. And I mentioned before, the technology is changing dramatically. We all know that. This is an indication of how it's changing. 5 years ago, we used to go out and do this by hand. We used to drive out to every milepost, the beginning of every milepost, and we try to say what the cracking was, the rutting was. Now they drive at highway speeds. 5 years ago, when contractors first started doing this, it was very labor intensive. The contractor had to look at their monitor and physically bring out their tools to measure those cracks. This is all automated, so the cost is coming down. And that's what we see. That's the reason, one of the reasons why we can do this project is we see the cost continually coming down. And so our appetite is getting bigger, even though our dollar amount is staying the same that we can spend on this. So because we have a pavement preservation program where we collect, we know what we have, we know the condition, we can put that into our pavement management system, and out of that comes this graph. This graph is telling us if we spend $200 million on our pavements for the next several years, this is what the condition of our pavements are going to be. This is both past from 2008 to the future 2016. This is what we need to do for all our assets, our safety. This is quantifiable, measuring what we have, figuring out the best maintenance strategies, figuring out the best treatments to preserve that pavement, and then we can show quantifiably this $200 million will get us this far. We want to do the same thing for safety, guardrails, rumble strips, cable barrier, signals, signs. It goes on and on and on. But because we've developed this program for pavement, we have a model that we can use. We don't have to reinvent the wheel. And so I didn't pull up these bullets as we were going, but this measures the International Roughness Index. It provides a historical look, and it also provides a forecast with trends and thresholds. Finally, what comes out of this pavement management system is a specific historical pavement condition, but also upcoming projects. So we want to do the same thing for signs, guardrails, safety. If you do these projects, they're the most cost-effective projects. They'll extend the life of that asset. And most importantly, our senior leaders will know if we spend X on safety, Y on pavement, Z on bridge, we have an idea of what that means for the overall health of the system. So having said that about pavement, now I'm just going to show you this slide. What if you were responsible for 100,000 or 400,000 of these things? They're signs. And I said 100,000 or 140,000 because when Scott and I and our group of 8 put together this RFP over a year ago, we had to put in this RFP how many signs we think we have. So I talked to Scott and his group, and I said, Scott, how many signs do you think the Department of Transportation has? Scott said 140,000 signs. But maintenance also has part of the responsibility for taking care of signs. So I asked maintenance the next day, how many signs do you think we have? And I didn't tell maintenance Scott's answer. And they said 100,000 signs. And so the question is, how can you possibly manage this asset if you have no idea how many signs you have, let alone where they are, the condition, the deterioration of those signs, maintenance strategies to prolong the life? How can you put together a plan? Remember the slides I showed you about pavement? How can you do any of that for signs? So before you can have a credible long-term program with funding recommendation, forecasting models, would you know the location, GPS mileposts of those signs, the size of them, the type, the condition, the retro, the good, fair, poor? Well, now we'll know how to do this because we'll know the location, the condition, the type, and we are working now with industry to develop a sign management system for those 100,000 plus signs. So now I'm going to turn it back over to Scott.
So as required and as maintained by all states, we have an inventory and a database of our crashes. As Stan has so well demonstrated and introduced, we haven't had a similar database and inventory of our assets, particularly assets that affect safety. Also, developing but not mature to this point has been a really good, comfortable grasp of our roadway geometry down to our cross-slope, super elevation, horizontal and vertical alignments, that sort of thing. Our plan with this data is to indeed combine all three of those elements and create a true safety management system that is able to analyze all of these elements to optimize safety in the state. To do that, we even had to take our crash database, which is quite robust and complete, and tweak it to fit into this model. So traditionally, as most states have, all of our assets are located by route and mile point. Well, as we move into this world, we have strived to convert everything in our crash database to a geospatial location system. By combining those crashes in that geospatial location system with our advanced GIS tools, we can start telling the picture to our leadership and to the public with a safety-focused message that is different than just our traditional method of looking at a column or a chart of data, where most people's eyes kind of glaze over when you try to explain what you're telling them. So we can start doing those type of analyses by spot, by corridor, statewide rankings and priorities, and display maps such as you see below to justify spending our limited safety dollars on the projects we want to spend. This takes us to U-Plan. U-Plan was started by planning and programming as a way to combine planning level data to do scoping reports for our long-range plan. It has developed into a platform to share all of these different data elements that we've been discussing today in a geospatial format. We have just finished an ambitious effort to upgrade U-Plan to an online format that leverages ArcGIS Online. And included in U-Plan are layers for safety and crashes, as well as all these other data elements that we will be combining together in a useful and easily accessible format. I think I covered most of these points here as we were on the last slide. I can't emphasize enough what the GIS platform brings to us, in that all of those interesting and creative analyses that people come to you and say, what if, or can we do this? All of a sudden you're not constrained by your own data sets and your own databases. For example, if for some reason you wanted to tell a certain county or municipality how many signs they have in their city, all of a sudden you don't have to tell them, well, city isn't a field in our database that we can query by, so I can't give you a number. You take a layer of their city boundaries that they may produce themselves, you lay it over a layer of your sign asset inventory that you just collected, and it automatically displays them together. You've all of a sudden got a piece of data that could not have existed before and did not exist before, and you combined and analyzed that data on the fly. So the more we think about the possibilities, the more the possibilities are endless. If anybody would like to see how this is working for us, the link to our website that shows you plan is there at the bottom of the slide.
So we're coming to the conclusion of our presentation, but I wanted to give you an idea of looking forward. When we started this project a long time ago, the joke was all we were looking for was pavement distress. And then we saw what technology could do for us, so we added assets. And as Scott said, we didn't stipulate the type of collection that the contractor needed to provide. We only wanted to know the relative location of those assets, the condition, the size, the shape. The winning contractor, Manley, used mobile LiDAR to collect efficiently all those assets. Immediately, we started asking the questions, could we use this point cloud for anything else besides assets? The contractor said no, because you're off about a meter. You could be off a meter, plus or minus a meter, in absolute accuracy. Relative accuracy was right on, a half an inch over 50 feet. For asset management, that's more than adequate. But for design, it's probably not adequate. But because we've had so much industry interest in this whole project, third-party contractors came to us and said, can we have some of the point cloud and show you what we can do with it? Manley has worked with those third-party contractors, and to give you an idea who they are, it's Oracle, it's Esri, it's Bentley, it's Agile Assets, it's Autodesk, it's Virtual Geomatics, it's Dayton. They've all wanted to show us what they can do with this point cloud. And the long and short of it is we are now calibrating that point cloud to survey grade accuracy. We're able to create digital terrain models and break lines in our MicroStation inroads CAD system. Not only that, is this point cloud gives the designers a great as-built tool. They can measure off this, they can sort and query, and so the project keeps on growing and growing as other people see uses for, they've never had the ability to know what assets we had out there. Now we do. And people see this point cloud and they say, wow, you know, I can use this for design. I could use this for as-built besides asset management. We've talked a little bit about the enhancements to UDOT safety program. Industry collaboration, I can't stress that enough. Industry has been great about looking at this project and saying, can we join this effort too? And so on August 15th of this last summer, we invited those groups that I just mentioned to a meeting, and we showed them more fully Manley's workstation and point cloud. And we said, gee, wouldn't it be nice if Manley could work with Bentley and get that into inroads? Wouldn't it be nice if Manley could work with Esri, more on a tighter collaboration on GIS? Wouldn't it be great if Manley could work with Agile Assets and Dayton on the analysis of those assets? And one thing that I have not talked about in here, there's just more than those companies. Since we had the August 15th meeting, we've had 3 other companies come to us over the last little bit. AAA has said, can we work with Scott in his group and Esri in their group and help develop a safety management system? We've had 3M come to us just the last week and say, can we work with Manley and Esri, Agile and Dayton to develop a sign management system? So these are these prototypes, the safety, the roadway design, the integration of analysis companies. It's quite an exciting project. We thought we were just going to collect pavement distress a long time ago, and now it's getting bigger every day. We'll stay tuned, and it will get bigger next week probably. But that's the end of our presentation, and we would entertain any questions, but there's Scott's email and telephone number and mine. So if you have further questions, go right ahead and start asking questions, and we'll see if we can see them. We're looking for the questions right now.
Stan, this is
Robert, we don't see the questions on our screen.
Sorry, Scott, what was that again?
We don't see the questions on our screen.
Rob Dingus, do you see the questions, and can you read them for us?
I'll tell you what. If you can hear me, let me just go ahead and start. We'll just start working through the questions one by one.
That's great.
All right. The first question was from Kevin Conlon, who asked, "What do you anticipate the biannual cost to be relative to the original collection?"
I'll try to give a go at that. The initial cost is $2.5 million. The contract has them to collect every even year. So 2014, they'll come out again. 2016. The payment cost is $850,000 for year 14 and year 16. Collecting assets again is going to be approximately $850,000 to collect all the assets again. But this is one of the great things about this project. Third-party contractors have come to us over the last 2-3 months, and they've shown us how they can superimpose 2014 point cloud on top of 2012 point cloud, and their software can automatically generate new signs, new guardrail, new width of pavements, and the cost is going to be significantly less than that original $850,000. I hope I answered that question.
All right. The next question would be, how were assets collected beyond the view of the mobile mapper systems and cameras?
That's a great question. The fact is, this is a line-of-sight data collection unit. And so things off the roadway, to a certain extent, are less able to be collected. The LiDAR itself projects 300 feet from the sensing unit. But if there's a barrier wall in the way, if there's a side slope that's hiding something on the side of the road, you can only collect what you can see.
All right. You mentioned earlier a 180-degree, I believe, as far as the video log. Did you consider a full 360-degree data capturing system like EarthMine or some of the others?
It wasn't in our requirements. Now that we have the 180, of course, our next question is, well, why didn't we get 360? But at the time, the 180, frankly, was a quantum leap in technology for us. We've done photo log for years, but the high-resolution nature of the images we're receiving now, it's incredible what you can zoom in and see. And that will probably be one of those generational steps we take from project to project.
And let me jump in that one of the most challenging things about writing that RFP was nobody had ever done this before, so we really didn't know what we could get with for our dollars. So our RFP was developed to have a base bid and then options, and we ended up getting every option, basically. But we thought, 360 camera, no, we're never going to be able to afford that, so that wasn't even an option. If anybody's interested in the RFP, they can send Scott or I an email, and we can send you the RFP, and you can take a look at it. That would be very helpful for any DOT who wants to go on this journey, knowing what you could get for your dollar and what's possible.
There were a number of questions related to the quality assurance aspects of this. Could you talk more about how you did separate quality assurance? And when you talk of survey grade, what type of accuracy are you achieving?
I'll start with the last part first, and I'll let Scott jump in on the QC. So the accuracy, we were a plus or minus 1 meter off on absolute accuracy before we calibrated it. After we calibrated it, we got accuracies of 1 to 2 inch accuracy, absolute. The way we did it was our surveyors went out and set control on the shoulder of the interstate here in Salt Lake Valley. The interstate in Salt Lake Valley, I-15, is 5 to 8 lanes in each direction. So every 1,000 feet, control was set, calibration was run, and the way we were able to show that that was absolutely on was we turned off half the calibration, and then we turned off half the control, excuse me. And then we ran the calibration. And we checked what the calibration was saying versus that turned off control. And we got within 1 to 2 inches of absolute accuracy. That's X, Y, and Z. Scott, you want to talk about QC?
So we've had a multi-pronged approach to QC/QA. We required each vendor in their response to the RFP to submit an outline of a QC/QA plan to be approved in contract negotiations. Each of the vendors approached QC/QA a bit different. I'll tell you how we're doing this one. We required an independent firm to join as a partner to each of the teams that were bidding. Manly has a local engineering firm that has chosen test sites throughout the state where they set control on. And every so often, for example, every week of their data collection initiatives in that area or that region of the state where data was being collected, the van would go back, the data collection unit would go back and rerun that section of road where control was set. And it guaranteed accuracy and consistency of the data collection units pass to pass, week to week as they were collecting throughout the state. Manly also has internal QC/QA controls on their extraction, the data extraction unit that they use. I'm sure it doesn't look like this, but I picture this back room, smoke-filled room of a bunch of computer techs just going through miles and miles of LiDAR and high-definition images, just extracting asset after asset. It's got to be a tedious task, but they have QC in place, and this is what's shared with Stan in that weekly stand-up meeting, where they randomly select assets and staff each week to check their work on a random basis, and they seem very willing and able to go back. For example, if a staff member seemed to be having a bad day, or there was a bad collection effort on a stretch of road, they would rerun the whole data collection, the extraction effort again for that section of road or for that asset, just to make sure it was on. And Stan is telling me with a thumbs up here, we've been impressed with that process they've been following. We've also had internal QC. Each of the groups that as kind of the owner of the certain assets and the data that's being collected is either having internal staff look things over, random checks, or hiring, in some cases, some consultants to help supplement internal staff to do that internal check so that we're happy and confident with what we're getting. We are very conscious of the fact that when we get this into the hands of our general users, if they have anything that they can blow a hole in and that will shake their confidence in what we've done here, it could sink us, and we don't want to do that.
All right, there's a question here about the locational scope. Now, this original project was just the state system, and they would like to know, what about local roads and expanding beyond the state system?
That's a great question. Do you want to say something to that?
I'll start, Scott, and you can jump in after me. We've given many presentations on this project over the last couple of months. Many people are interested here in Utah and around the country. at one of the presentations, the local MPO came up to us and said, have you ever thought of doing this on federal aid eligible routes? And I said, it'd be a great idea. We have LRS now for our federal aid routes. We'd be happy to work in conjunction with our local partners. And so the local MPO is going to go back to the cities and towns and say, hey, how about this technology? Do you want to possibly use it at a minimum on your local government roads, Fed aid roads? And it might be collection on a lesser scale than what we're doing here at UDOT. So we're exploring that. People are talking about it. But at this point, we don't have any signed contracts with cities and counties. Scott, do you have anything you want to add?
I'll just add, as the safety representative in the room, as many of you know, our HSIP, Highway Safety Improvement Project funding, is eligible for all public roads. One difficulty we have in allocating that funding to locals is how to have a data-driven approach to how to allocate those funds between state routes and local routes. And institutionally, we are very supportive of partnering with our local agencies to see if we can extend some of this onto the local system.
There's a question here about retroreflectivity. You're collecting the signs. You talked about trying to get an accurate count. How about minimum levels of retroreflectivity or getting a better feel for the visibility of your signs?
That's a good question. You know, the first part of data analysis is know where you are, know what you have. The next part is what kind of condition do you have of that. And so the contractor is going to do a visual inspection of every single sign, good, fair, poor, and further subdivide fair and poor into three categories. Is the sign bent? Is the sign faded? Is the sign have graffiti on it? That's for both fair and good. So we'll be able to develop that management system based on not only what we have, but the condition, the visual. And then we are going to do retroreflectivity on 1,000 large interstate signs across the entire state of Utah on I-84, I-80, I-215, I-15, and I-70. And from those 1,000 signs, we hope to create a statistically significant database of if a guide sign faces south at this elevation, and the retroreflectivity is this, and the sign has been in X number of years, we hope to be able to translate that across many of our signs with those attributes I just mentioned. So they're going to start doing the retro here in another couple of weeks. They're using Facet out of the Midwest as their retroreflectivity company.
I would like to mention collecting retroreflectivity at highway speeds seems to have been the one tipping point where we were a little bit ahead of technology. Everything else seems to be very doable with current technology. Companies like Facet were still developing their algorithms when our RFP was on the street. And so we included a test, if you will, of the technology. Ideally, of course, that sensor would be on the collection van at the same time everything else was being collected, and it was just another feature data point being collected. But that's an evolving technology that we may have gotten in front of just a bit. I will mention a lot of people have also talked about measuring the signature return from the LiDAR itself and being able to collect condition of the retroreflectivity of the sign just off the LiDAR signature has been talked about. But again, the algorithms haven't been developed and refined yet.
And preliminary look at that idea is our point cloud may not be dense enough to get a good intensity reading off our signs. We're still working on that. We're still talking to several other companies to see if we can pull that off.
All right, gentlemen, that's excellent. We'll throw it back over, I guess, for some final remarks from Lincoln Cobb, and then that'll do. we'll be done.
First, I just want to say thank you to Stan and Scott for sharing their experiences. This is a very important step in the direction of, I guess I'll say, standards in the broadest sense. But for us to learn, all of us in the community, to learn how to specify this sort of work, for the vendor community to be able to respond more effectively to this sort of solicitation when it goes out. All of us will benefit at every level from a developed ability, comprehensive ability to go from the very earliest stage all the way through to the second and third and the fourth cycles of data collection with high quality data that can be relied on and on which we can base the decisions that we need to make with resources that are becoming increasingly scarce. So that's the end of my little soapbox. Again, thanks to all. I think I saw a peak of 89 attendees out there. We appreciate your time as well. Thanks very much, and have a good day.